class is specifically designed to declare objects to be thrown as exceptions. The exception class has a virtual function called what that returns a C string, and this function can be overloaded in derived classes to provide a description of the exception. Let's take a look at how this works. We'll make a working copy of exception.cpp, paste this into our working project. If we compile this and run it, you'll see we have an exception. Now let's start in the main so you can see what happens here. We see out the string, let's have an emergency, and then we call a broken function that does nothing but throw an exception, and we return 0. So here's the broken function, and there is the terminate because we're not catching the exception. And you'll notice that it's printed at the end here in red, and red is because it goes to standard error. And sometimes when I run it, I'm just going to run it again here, and yeah, there it's at the top. So if yours is at the top or yours is at the bottom, don't worry. It's because the normal cout is buffered and the normal standard error is not buffered. And so these will come out in whatever order they feel like, and there's no real controlling that. When we throw my exception, what happens? What is my exception? So my exception is this class up here that inherits the exception class. And you notice that I've included the exception header so that we have access to the exception class. And class myException is derived from exception as a base class. And exception as a base class, it does very, very little. It's a very simple, small class. And one of the few things that it does is it declares a what method as a virtual function so that we can override it. And you'll see that this over here, it says overrides, as opposed to, it uses a different word when it's not a virtual class. But you really want this to be a virtual class. It's designed to be overloaded. And so this is pretty much how the exception class is designed to be used. And so all we do in this myException class is we overload the what method, and then we define it down here. You'll notice that it has the const qualifier, and it also has this throw specifier. And the throw specifier, this specifies what exceptions it's allowed to throw. And by having it be empty, that means it's not allowed to throw any exceptions. And so it's important that you use exactly this signature when you're overloading the what function, because if you don't, it won't work. Simple as that. It'll overload something else and it won't get called. Or more likely, it won't overload anything and it won't get called. So here's our version of what, myException what, and it has exactly the same signature here. And it simply returns a C string, and because it's defined to return a C string, and the C string just says, oh no. And you see here, we got what, oh no, as our exception. So that by itself is very convenient and very useful. You can have an exception that says a particular message. So if instead of just calling broken like this and letting it come out and terminate the entire program, we can actually catch that exception. And we do that like this. I'm going to put all of this code in what's called a try block. And let's take this and cut and paste it into the try block. And then we have to catch when we have a try block. And we catch like this. So what the try block does is it encapsulates a whole bunch of code. And if anywhere in that block an exception happens, then it tries the various catches. And you can have more than one catch clause if you want to that specify a different type of exception. And in this case, we're just using the exception class. 99 times out of 100, you're going to not want anything different than that. And we're catching the exception as a reference, and we simply call what on it like that. So now when I save this and run, you'll notice that it says, let's have an emergency. This is a broken function. Oh no, now comes to cout. It does not go to cerr anymore. It's not in red. It doesn't terminate the entire program. You can actually catch this and keep going if you want to. In fact, let's do that. We'll come down here and we'll say cout. This is still running. How about that? We'll save and run, and you can see we're still running after the exception. So one more thing I want to show you here, because our exception class is actually pretty inflexible. It only does the one thing. It only returns that one string. We can make this a little bit more flexible. Let's define a constructor. that takes a C-string message, and we'll put it someplace. We'll use a string class for this because it's just a little bit easier to work with. And we'll construct that class with the message, and we'll just have an empty block there. Now in our what, we can return that class as a C-string. Simple, huh? Now, when we go to throw our exception over here, we can give it a string. And when I save this and run it, you see now it says ouch. And so for different functions and for different places, I can now have different messages. And all I'm doing here is I'm calling just the constructor for my exception and letting throw the temporary object that's returned by the constructor. And so that's what gets caught by the exception here, and we get the what, and then the object is gone after that. So this is a very convenient way to do this, but it's not very scalable. If you have a large system, you could end up with a whole mess of different error messages. So instead, you could define a whole bunch of them in one place, and you could have const my exception, ouch for the one that says ouch. You could have, let me just copy this and paste it a few times. You could have one you could call bad, and over here you could say bad code. You could have a whole bunch of different messages. And then, let's define this up above here. Put it up with our class there. And then down here in broken, instead of throwing my exception, you could throw worse. And now, when we save and run this, it says, don't do that. And so now you could have a limited number of exceptions, and you could comment them, and you could keep track of them and use them intelligently depending on what's going on and what sort of an error that it is that you want to throw. So now we have a fairly flexible and powerful system of exceptions, and look how easy it is to define. So C++ exceptions provide a simple and effective way of handling errors and other exceptional circumstances at runtime. The STL exception class is well suited for declaring objects to be thrown as exceptions. The exception class's virtual what function can easily be overloaded to provide for a variety of exceptions. Now let's delete our working file.